Hello friends. So today we are going to take a session on a smart Google Glass using which we can embed a phone. So like in last live stream, you have already seen if you are there in the last live stream that we have made a smart Google Glass using which you can get the notifications and many data on the on your spectacles or your eyeglass that you put on your eye, like this, something like this. And like Iron Man, you get all the data of your body health or whatever data you want to show. You can get that directly on the Google Glass. And we have tried to design the Google Glass in the last session. So we are extending that same the project and trying to embed a phone in the Google Glass itself. So we will embed a phone in this glass with a transparent display like this, and this, as you can see, this display is so transparent. You can see, आप इसके आर पार देख सकते हो, इस डिस्प्ले के आर पार आप देख सकते हो, जैसे कि आप देख रहे हो कि डिस्प्ले पूरा ट्रांसपेरेंट है। तो हम ऐसे ही एक ट्रांसपेरेंट डिस्प्ले और एक ग्लास को, आई ग्लास को लेकर के हम लोगों ने लास्ट सेशन में एक गूगल ग्लास बनाया था, और उसी गूगल ग्लास को आज इस सेशन में हम एक्सटेंड करेंगे और इसी के अंदर हम एक फोन एम्बेड करेंगे, जिससे कि आपका क्या होगा, आपका ये गूगल ग्लास एक प्रकार का फोन बन जाएगा। और इस ग्लास को पहने ही आप बात कर सकते हो, नोटिफिकेशन पढ़ सकते हो, मैसेज भेज सकते हो, और इस सेंसर के थ्रू आप उसे कंट्रोल कर सकते हो। तो इस सेशन में हम इसी के बारे में बात करेंगे और ऐसा ही एक स्मार्टफोन एम्बेड करेंगे इस ग्लास में और इस गूगल ग्लास में। और यदि हो सकेगा तो हम इसका एक और नेक्स्ट सेशन भी लेंगे और उससे से डेमो बना करके आपको दिखाएंगे कि कैसे होगा, क्योंकि इसमें हम नॉर्मल एक सिंपल फोन बनाएंगे, उसमें और भी अलग अलग एप्लीकेशन लेंगे। सो लेट्स बिगिन द प्रोजेक्ट विथ basic component that we require in the project. So like if you have already attended the last session of a smart glass using Google Glass and transparent OLED, you already know the components that we use. I am repeating again, and if of those previous component, we need few more extra component. हमें कुछ और भी extra component भी चाहिए होगा। तो चलिए देखते हैं कि हमें कौन कौन से कंपोनेंट चाहिए होगा। तो हमारे गूगल ग्लास के लिए सबसे पहला एक ग्लास तो चाहिए ही होगा। इस प्रकार का एक ग्लास आप ले लेना, जैसा कि आप देख रहे हो, इस प्रकार का एक ग्लास ले लेना। You need a glass like this, a transparent glass like this, and then you need a transparent OLED display. This is SSD 1309 OLED display, and you can buy many other OLED display out there in the market of many various vendors. But all those OLED display come with the same SSD 1309 driver. So you need a transparent OLED display. OLED display for the Google Glass as well. You can see, you can see my fingers, and it is so transparent. You can easily see. So, and the next component we need here is this RPi board. This is the Raspberry Pi board. You can make the size of this whole Google Glass and put the whole component inside the small, fit the whole component inside the small spectacles by removing this RPi board with any other microcontroller or any other version of board, smaller RPi version of board like Raspberry Pi Zero. And above that, we also need though we are trying to make a phone, जैसे कि हम सभी जानते हैं कि हम एक फोन बना रहे हैं, आई ग्लास के अंदर हम एक फोन इम्बेड कर रहे हैं, तो हमें इसलिए चाहिए हुआ एक GSM मॉड्यूल। तो हम इसमें यूज कर रहे हैं SIM 800L GSM module. This is a 2G GSM module. So we are going to use the SIM 800L GSM module, that is 2G GSM module. But as you know, the 2G spectrum is getting closed in many area day by day. So you can change this GSM module with any other 3G GSM module like SIM 8900L or any other GSM module. I have already the SIM 800L GSM module, so I am using this. So these are the components I'm going to show you all these components that I'm going to use. So these are all the components that we need. And above this, you also need a battery, but here we are trying to make a prototype, so we don't need a battery. We directly power it using the laptop over the USB device. So let's start making. So if you have already attended the last session of the Google Glass, we need some library to use this OLED display. So if you're not aware of that, then I will going to tell you again. So for that, first you need to power the RPi board. This is the RPi board. I'm going to power it, and then we will open the BNC module, BNC viewer. So I am opening the BNC viewer here. And I am going to open this. We need to wait few minutes so that RPi get connected to the internet, and then it connected to my BNC viewer, and then the desktop of RPi board will open here. So let's wait for few minutes. So जब तक ये RPi बोर्ड हमारा कनेक्ट हो रहा है हमारे वाईफाई नेटवर्क से और हमारे लैपटॉप से, चलिए हम आपको और कुछ चीजें बताते हैं। तो हमारा जो ये आई ग्लास है, जैसे कि मैंने आपको लास्ट सेशन में बताया था, ये हमारा ये आई ग्लास है, ये दोनों मोड में काम करता है। SPI 1 मिनट। सो हमारा RPi बोर्ड रेडी हो गया है। मैं यहाँ पे पासवर्ड डालूंगा और मैं अपने रास्पबेरी पाई का डेस्कटॉप को अपने कंप्यूटर को ओपन कर लूंगा। सो जब तक ये कनेक्ट हो रहा है हम इसके बारे में बात कर लेते हैं। तो इसमें जैसा कि आप सभी जानते हो कि इसमें दो प्रकार का कम्युनिकेशन सिस्टम है, एक I2C बेस्ड है, एक SPI है। तो SPI में आपको 4 पिन यूज होंगे और I2C में आपको दो पिन यूज होंगे, 2 पिन पावर के लिए यूज होंगे। तो मैं इसके कम्युनिकेशन को 4 पिन यूज करने में थोड़ा कॉम्प्लिकेटेड होगा, कनेक्शन करने में थोड़ा कॉम्प्लिकेटेड होगा, एक भी वायर थोड़ा भी यदि आपका लूज कनेक्शन हुआ तो आपको काम नहीं करेगा। So because of that, because SPI using lots of more pins, so we are using the I2C communication. So to put this OLED module in the I2C communication, you got a 2 register here. So what you need to do is to desolder this register from SPI and resolder this register to I2C. So I have already soldered it, as you can see. I have desoldered the SPI register and soldered it to I2C. Now this OLED display will work on I2C communication. So this is how you can switch the communication of this OLED display. And when you switch to the I2C communication, the D-in pin became the SDA pin, and CLK pin become the clock pin, and the VCC goes to 5 watt and ground pin goes to ground. So now let's see our Raspberry Pi get connected or not. 1 minute. It is facing problem in connecting the RPi board. So now our RPi board is ready. So let's first understand the process of making this. So here we are using the SIM800L module for making the phone embedding the phone inside our eyeglass, our smart Google Glass. So for that we need a library so that we can interface this SIM800L module. This SIM800L module, this SIM800L module will work on USART, or you can say the serial communication. So it has 2 pins, RX and TX pins. So RX and TX pin connected to the should be connect to the RPi board, and so then only we can able to communicate with this, and we will able to get the message phone or whatever we want to whatever the stuff we want to do. We can make a code and do those steps on this module. So let's first install the GSM module. For that we need a library, and the library we are going. There are also many libraries for this SIM800L module to getting it communicated with interfaced with the RPi board and using it. But here we are using the library GSM hat. So let's go to the 1 minute. Go to the RPi board GSM hat pi. Yeah, this is the library that we are going to use. So we will install this library on the RPi board. Here we go and open the terminal, and then type sudo pip3 if you are using Python 3, and then the name of that library. So I've already installed the library. So it said the requirement already satisfied, but if you have not installed, then the library got installed here. So after installing the library, you need to install the library for this OLED module. So for that, you need to install the Luma OLED library. And after that, you will able to interface this this transparent OLED display. So mm, so we will connect this OLED module and this SIM800L module with the RPi board, and then we will make a code using which we will able to interface this SIM800L module and show the data of the incoming call or sending message or making call on this OLED module, and using this sensor we will interface it. So let me show you how our phone looks, something like this. So when someone is calling, it will show you like this. Uh, so let me show you the circuit diagram, how we connect these things. So here is the circuit diagram using which you can get how we are going to connect the modules and and all of this. So I've already told you regarding the OLED display. So we have set this OLED display into I2C communication mode. So we will connect the SDA pin of the OLED display to the SDA pin of the Raspberry Pi, and SCL pin of the OLED display to SCL pin of the Raspberry Pi, and the ground pin of the OLED display to ground pin of the Raspberry Pi, and the VCC VCC pin. And I have already told you the SIM800L module. So this module will work on the hardware serial communication with the RPi board. So we will connect the RX pin with the TX pin of the Raspberry Pi, so that it will receive the signal from this, and the TX pin to the RX pin of the Raspberry Pi. So after this, you need to power the SIM800L module. So you need to power it with 5 volt or 3 volt. But 5 volt will little bit greater for this small module, so you can power it with 3.3 volt. After that, you need to connect the ground to the ground. So after connecting this module and this module, you are done for the communication of this OLED display and the SIM800L module with the RPi board. Now, for any phone, you need a speaker and a microphone. So we have the mic pin in the SIM800L module, that is MIC plus pin and MIC minus pin. So we will connect a microphone, a condenser microphone, and another microphone, small microphone that you find in the market, and then you will need a smaller speaker, and then you need to connect this. So let me show you in the video, on the live video, how we have connected it. So as you can see here, so as you can see, आप जैसा कि देख सकते हो यहाँ पर कि हमारा ये SIM800L मॉड्यूल है, इसमें मैंने एक सिम कार्ड डाल रखा है, और इसके पिन में 1 मिनट में थोड़ा जूम करता हूँ। हाँ, यहाँ पे इसका सबसे पहला पिन एंटीना का है, तो मैंने एंटीना का पिन कनेक्ट कर रखा है। फिर हमारा ये RX पिन है, और फिर हमारा TX पिन है। तो मैंने RX पिन को रास्पबेरी पाई का RX पिन पे कनेक्ट कर रखा है, और TX पिन रास्पबेरी पाई का ये TX पिन पे कनेक्ट कर रखा है। ये रास्पबेरी पाई का TX पिन से मैंने कनेक्ट कर रखा है। 1 मिनट मैं आपको जूम करके दिखाता हूँ। हाँ, ये हमारा RX पिन में जाएगा, और TX पिन, the TX pin goes to the TX pin, and RX pin goes to the TX pin of the Raspberry Pi. So for the receiving pin of the Raspberry Pi of serial port will go to the transmitter pin of the SIM800L module, and the transmitter pin of the Raspberry Pi go to the receiving pin of the SIM800L module. So RX go connected to TX and TX connected to RX module. So this is how you will need to connect. And then I have connected let me zoom it. Then I have connected this thing. I have connected this microphone to the mic pin, and this speaker pin to the speaker pin. So after this connection, we are done with the communication of this. So let's first create a code using which we will able to communicate this SIM800L module and try to retrieve some message or make a call using this module. So for that, we need to create a code. First, let's test this. So this is the code that we have created. So here first we will import the GSM hat Python module that we have installed. So using this piece of code, we will import that Python module, and then we need to set the serial port name of on which our GSM module is connected. So here my serial port name is dev TTY S0. if you have different version of Raspberry Pi or with a different flavor of the OS, then this name might got changed, but generally this name is the same DVTTY S0. After that, you need to set the baud rate on which the SIM 800L model will work. So the default baud rate of the SIM 800L model is 4800. तो हमारा जो SIM 800L मॉडल है उसका डिफॉल्ट baud rate है 4800. तो हम इसका baud rate सेट कर लेंगे, बट ये आपका वेंडर और मैन्युफैक्चरर और टाइप ऑफ वर्जन ऑफ जीएसएम मॉड्यूल के हिसाब से चेंज होगा. तो यदि आप 900 यूज कर रहे हो, आप कोई और वेंडर का आपने खरीद रखा है जीएसएम मॉड्यूल, तो ये डिफॉल्ट baud rate उसका आपको वेबसाइट पे चेक करना पड़ेगा, जिस वेंडर से आप खरीद रहे हो उससे लेना पड़ेगा और वो यहाँ पे इंटर करना पड़ेगा, तभी आपका वो कम्युनिकेट हो पाएगा. नहीं तो फिर वो आपको एरर दिखाया कि आपका नहीं हो पाया कम्युनिकेशन. फिर हम इसे चेक करेंगे कि कोई नया मैसेज आया कि नहीं. Then we will try to check if using this piece of code, we will try to check if there is new message came in the GSM module or not. If the new message came, then it will read the message and then read that message. So we will save this code and then we will run this code, and for that I have problem when I run directly from here. I got problem of permission, as you can see. I got permission error. So here what we will do, we will open this folder in the terminal, and then we will type Python 3 sudo with the sudo Python 3, and then we will run this code. So when I run this code, what it will do, it will communicate to the GSM module and try to extract if there is new message, if there is unread message in the SIM card or not. If there is unread message, then it will print out the message read from the GSM module. So this we are testing the GSM module is more successfully connected and we are able to read the message. So let's do it. So first we need to install the Pi serial library. I've already installed. I don't know why I'm getting this error. 1 minute, I'm trying it again. I don't know why this is giving the error right now. 1 minute, let me check it. So due to the version problem or the serial Python module, you might got this kind of error. So you need to figure out how to do it. And then, so I'm trying to reboot the Pi. Let's see if I start everything with press, it will run. So let's hope so. So I'm going to turn off the Pi and try to start it again. For now, the Raspberry Pi is connected to the laptop, and so let's move on to the another stuff, and then we will after opening the Raspberry Pi, and we will reconnect this GSM module, the GSM module of the Raspberry Pi. We will test it and we will try it. So for now, let's understand how we will set up this thing on this Google Glass. So here we will put this thing here on the Google Glass, either like this, but if you put the layout like 90 degree, you can also put it like here, and at this section you have to mount the Raspberry Pi. So after mounting the Raspberry Pi on this section, you need to put the battery side here, and then you need to then you need to connect this to the I2C pins, and then you have to mount a small battery with the 5-volt 5-volt buck booster, and so the Raspberry Pi can get powered. And after that, when you run the code, when you make the code to the phone and run it, you will get the whole message on the OLED glass. So let me reconnect my Pi. I'm going to reconnect my Pi. So as you can see the screen, I have reconnected the RPi board, and then now let's open this thing again, and let's run the code again. Yeah, now the code and what we have some connection problem, or I don't know what the problem at that time. So now when I run the code, what the code will do, it will try to connect with the SIM 800L module and try to figure out if there is any new message or not. And as you can see, there is a new message, so it received that message and display here. There is a message here, and what is the message is, it is display on the uh, 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 here. So after that, uh, now let's create a code for our OLED module. So here is our OLED module code. So here is our OLED module. So we will combine the both code of OLED module and the SIM 800L module. And after combining this code, we will create a code, and we will try to make some logic. We will create some logic. So let me tell you what I have done. So here first we will import the OLED module Python module, the transparent OLED display Python module. After importing the OLED display Python module, uh, uh, we will import the GPI 0 module. We are going to import the GPI 0 module because here we will connect this ring pin, this is the ring pin. This is a ring pin to the GPI number 17. So whenever we make a call on the GSM module, it create a ring, and due to this creating a ring, uh, this provide a 5 volt voltage, and so the digital read of that pin number 17 will detected by the Raspberry Pi, and it will show us the message the phone is ringing. So we will connect this pin to the ring pin, pin number 17, and after that we will connect this OLED display. So I have already told you, we connect this OLED display to the Raspberry Pi here, and like this OLED display, this is a ground. This is the this is 5 volt, and this is the ground. Here, this is the ground. This is the ground pin. Ground pin is, let me check the one more ground pin for the other available ground pin on the Raspberry Pi. So let me check it. So to check the pinouts of Raspberry Pi, just type Raspberry Pi, and then go to the pinouts of the Raspberry Pi datasheet, and you will see there is one more ground pin. So my this ground pin is already connected with the SIM 800L module, so I am not going to use this ground pin. I will now be able to connect my OLED display ground to this pin. So I have another ground pin here, pin number 9. So I will connect the ground pin to the pin number 9 after the 4 pin, 1 2 3 4 pin. So after 4 pin, I have a ground pin on the RPI board. So after 4 pin, here is my ground pin. 1 2 3 4. Here is my ground pin, and then we have the HDA pin. HDA pin is after the 3 volt pin. So this HDA pin connect to this pin here, and this SCL pin will connect to this SCL pin. So after connecting this, you need to check that the connection is successful by a command on the Linux terminal. So you need to open the Linux terminal and check the OLED display is connected or not. So after that, we will check the OLED display is connected or not. So I2C detect Y1. So when I type this, if my display is connected successfully, it will return the I2C address of this display. Yeah, now our display module is detected by the RPI board. This is 3D. So it return the I2C address, that is the 3D. So this is my I2C address of the of this display. So after successful connection, this is we will able to get the display I2C address. So we will put this I2C address here in the code, and so we will note this our I2C address is 3D. Our display address is 3D. So it's depending on the vendor of display and type of display, this I2C address will be changed. And my display connection is little bit loose, so it is getting disconnected again and again due to some wires on the breadboard. So after that, we need to set the we need to set the I2C address in the code, that is zero. This is the hex code 0x3D. So this is the display I2C display address, and this is the port number 1 that we are using on the RPi board. After that, we have also declare some some buttons on the RPi board, so that we can able to interface the sensors on the eyeglass, and the ring pin from the SIM80L module, so the Raspberry Pi will able to get if there is incoming call or not. If there is incoming call, so if there is any incoming call, it will show us the ringing message, and it will also display on the OLED display that there is a incoming call like this, using this piece of the code. And then we will check if we want to read some kind of message, then we will check if there is some new message or not. So using this piece of code, gsm dot available sms dot available is greater than 1. So this will check if there is any unread message. So if there is new message, it automatically show you that there is unread message. So if there is unread message, so it will read this message, and then it print out those messages on the OLED display using this. And then if you want to make a call, so it will check from the our eyeglass sensor that if we are trying to make any call or not, and then we have declared the number of which we want to call, and then this will make a call, and until it will display the message of that it is making a call. So this is a piece of code. You can customize this piece of code as many functions as you want, and as many things as you want to add in the code. So this is the very simple code that we want to try it out and check it out whether we will able to implement this or not. And after that, we will need to fix this display model to the to this eyeglass like here, and this sensor module, we will connect this sensor module into to the here. So first check this, let's check this eyeglass module. So when you run this code, when you run this code, 1 minute, first we will connect this. So when you run this code, it will check if there is new message or not, or something like that, and then it will display you message like this, something like this, the message like this, that someone is calling, and you need to pick up the call like this. I have getting some loose wire connection on the OLED display. So I'm showing the demonstration testing video of that like this. So if there is new message, it will show you the message like this. Someone is ringing or someone is calling like, and you can see the you can see the OLED display is transparent, and so you can see the finger from the OLED display, and so you need to fix all those components on the eyeglass, and you will be able to make the eyeglass a smart eyeglass like this. So that's it for, and you can even make a smart custom UI like this, so that it will look cool. Like you can set the text, you can set the text size small, and then get the battery battery capacity as well, and then they will need to set a full page menu like this, and when you run the code, it will show you like this, and when someone will call you, it will show you the message like someone is calling, and you can see the display is transparent. It will go to the you can see through the display like this. So this is for the today, and if you have any doubt, you can ask me, and we will show you the live demonstration of this whole project, this whole thing again in the next session. I have some loose connection on the on the breadboard. I have to figure out where the connection is loose. So everything will be demonstration in the next session. And if you have any doubt or any question you want to ask, you can ask me. So we will try to make this smart eyeglass to the next level. We will also try to add some application and games to this eyeglass, using which you will be able to using which you are able to get the get the games. You can be able to play the games light on the right on the eyeglass, on this eyeglass like this. 1 minute. Uh, on this, and you set this thing here, this thing here. You set this eyeglass here and the Raspberry Pi here, and you can wear it, this eyeglass, and then using this eye blink sensor you can play the Floppy Bird games and many more cooler stuffs. 1 minute, let me show you. Like this, and using this eye blink sensor you will able to interface this thing, the phone thing, and this Raspberry Pi, 1 minute, let me show you. This Raspberry Pi and the whole component will fit like this, so everything got fit like this, and you will get all the message of incoming call, and all the weather report, or the you want to text, read the book, or you want to know how fast you are riding the bicycle, and every other details you will get here, right here on the display, and you can see through the display because it is transparent. So this is how you can make a smart eyeglass, and in the next session we will show you the proper demonstration, live demonstration of this with the Floppy Bird games on this OLED module, or any other kind of application like opening the calculators or reading the books on this OLED display. So we will make a different application. So if you want the next uh, uh, you know, if you want the next live demonstration of this, you can ask me for that. And if you have any kind of question and doubt, you can ask me. And the whole code and the project and the demonstration video, live demonstration video, will be published on electronsforyou.com soon, up in upcoming month. So this is undergoing project. We are trying to implement some more amazing features to this eyeglass. So after that, you will see this smart eyeglass phone on the Electrons for You on in upcoming month with a live POC video. And if you want to know about how we have made a smart Google Glass, that is already published on the electronsforyou.com. You can check it, and you can also see the live video and making video of that live session. So that's it. Thank you, everyone.